In the previous examples, we have seen how to draw an equation given the slope and the y-intercept. And we use that information to estimate 2 points through which a line will go through. What if we are given those 2 points and we were required to find the equation of the line? So let us see how we can accomplish this. We are going to use the information from the previous example where we were given 2 points, 2 sets of points, x and y. Again, x is the independent variable and y is the dependent variable. And we had 0 and 1 and 2 and 5. From the previous analysis, we also define b to be equal to 1 and m to be equal to 2. So now let us understand how to evaluate these values for b and m given this set of 2 points. I'm going to call the first set of points set 1 and the second set 2, which implies that we are going to have an x1 and a y1 and an x2 and a y2. Remember that we still have these independent and dependent parameters. The equation for a line given these 2 sets of points is the following: y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. In this equation, we observe that we have the known quantities y1, y2, y1, x2, x1, and x1. But we still have the independent parameter x and the dependent parameter y. The equation for the line can now be numerically evaluated if we substitute the numbers in this expression. So here we will have y minus 1 is equal to 5 minus 1 divided by 2 minus 0 times x minus 0. And if we perform the algebra a step further, we find out y minus 1 is equal to 4 divided by 2 times x. Or 4 divided by 2 is equal to 2, so it's going to be 2x. And if we take the constant here and move into the right-hand side, we find the final equation as y equals 2x plus 1. What I'm going to do now, I'm going to compare this with the standard linear equation that we introduced, y equals mx plus b. And what do you observe? We observe that the slope m, which is the coefficient multiplying the independent variable, is equal to 2, and that the y-intercept or the constant b is equal to 1. And these values are the same values that we've used in finding the points used in evaluating this expression. As an exercise, I would like for you to evaluate this equation by swapping the second point and making it the first one, and take the original first one and making it the second one. So basically, your points now will be 2 and 5, 0 and 1, and apply them into this equation and check if you do get the same answer as the one I evaluated. So this exercise will allow us to understand if defining the first set and defining the second set as 1 and 2 are important, or if we can swap the sets and we end up with the same expression.